Okay, now let's go through this code one more time, and we're going to convert all of those queries to the database abstraction layer. Go ahead and jump to your module directory. Let's open up the fifth step, which is called Update SQL. Go ahead and copy the entire code, and then paste it over the code currently in your trails.module file, and save it. Okay, now we only really need to look at these last three functions that we added: Trails History Add, Trails History Fetch, and Trails History Prune, because these are the three functions that take care of all of our interaction with the database. Let's go ahead and start with Trails History Add here. So the only thing we've changed is the query, and we've commented out the original query so we can compare it with the database API version. You can see that the structure is actually pretty similar. Whereas here we have insert into Trails History, we have DB insert Trails History, and then we have a row for each column that we're going to fill in, and same here, we have a row for each column we're going to fill in. The rest of the structure requires some explanation. This DB insert function is a wrapper function for an object that's created that includes a number of attributes and methods. By calling DB insert, we're basically instantiating an object and giving it a number of attributes, telling it that we're going to do an insert statement. And the parameter that we're passing is the name of the table here. One of the methods that this object has is called fields. And what fields does is allow us to assign values to various fields. And in the case of an insert query, this means that these are values that will be inserted into these columns as we process the query. It also contains one more method, which is called execute. And this is after the query has been built, then execute needs to be run in order to actually process the query. Now, if you haven't worked with objects much, and in Drupal, up until this point, a lot of things have been array-based and function-based rather than class-based, then this structure might look a little strange at first, but it's actually very powerful. So you might have used the user variable before, and in order to get attributes of the user variable, you have to use this arrow sign that you see here. So we can get the UID by using the dash and then the forward bracket and then the name of the attribute that we want to grab. The difference with the object that's returned from DB insert is that it contains methods, which are basically functions that belong to the class, to the object, and that function already has all of the data that's associated with the class. So we don't have to tell it explicitly certain things every time we run a function in it. That's what makes a method so powerful. In addition, the way that the database abstraction layer structure works is that every time a method is called, or at least for many methods, an object is returned that's identical to the previous object with whatever changes have been made. So we can daisy chain methods together. So that's exactly what we're doing here. We're taking the object that's returned from DB insert, and we're running the fields method on it, and we're just passing it a single variable, which is an array, and that array contains a number of key value pairs for our fields. And then once we run this method, the same object that got returned by DB insert is returned again. And so we can then run another method on it, and that's going to be execute. Now what this means is that if we wanted to, we could split this up into several different commands. So the first one could be DB insert, and we can return a query from that. And then we can run fields on that. And then on another line, we can run execute. And then between those lines, we can perform any conditional statements that might change the outcome of the query. So if, for example, we wanted to use the default title here, but if a certain parameter exists in the query string, we want to grab the title through some other method, we can do that by just putting that in between two other statements that are building our query. And this is the nature of a dynamic query, and we'll go over this in detail in one of our later examples. Finally, one other thing that's different about this style of querying is that typically the functions will return a value. And in this case, it's going to return the unique ID of the row that was inserted when this query ran. So we can actually return a useful value from this function. So that's what we're doing here. We're taking the THID, or the Trails History ID, and we're returning this as a useful but maybe not necessary return value.